Welcome to my light board videos. In this video I'm going to show you how to find basic probabilities using a contingency table. Here's an example. 500 adults were surveyed on whether they would favor or oppose a new tax law pertaining to increased funding for education. So we have what we call a contingency table right here. You can see the 500 adults are divided into male and female categories. We have a total right here. The 247 means there were a total of 247 male who took the survey and 253 female adults who took the survey. You can see there is a raw total right here. The 300, what does the 300 mean here? Support. So there were 300 adults who support the tax law, the tax proposal. Oppose, there were 159 in total, including male and female, who opposed the law, and 41 they were unsure. There could be 41, some of them are female adults and some of them are male adults. What does the 500 mean? The 500 here means the total number of people who took the survey. This is called the grand total. Understanding the table is very important in order to answer the questions. Now let's go to the questions. The first question. We select one person at random from those 500 adults. What is the probability that the person that we selected opposes the tax proposal? Okay, in order to find the probability, the classical definition of probability is the probability of an event is the number of favorable outcomes, the outcomes that would work in the favor of the event divided by the total number of all possible outcomes. So what would be the probability that a person opposes tax? We're selecting one person at random out of 500, so the number of possible outcomes is 500. Now ask yourself a question. How many outcomes would work in the favor of opposing tax proposal? So how many oppose? Well, there were 159. We don't care whether the person is male, female. We just say it's the person. It doesn't say female or male, so oppose tax 159. So the answer will be 159 divided by 500. If you were asked to round the answer to 2 or 3 decimal places, just do the division, but I'm just going to keep the fraction there. Second question. A person selected at random, what's the probability the person opposes the tax and is a female? So now we want the person to oppose the tax and is a female. So there is an intersection here. So probability of A and B. If this event is A and this event is B, he's asking us to find the probability of A and B. Here's how you do it. Okay. We go to oppose, right here, this is the column. And female, it's the column. We want the ones who oppose the tax proposal and are female, so we need the intersection of the two. Where does the female row intersect with the column row? Right here. So these are the number of people that are the favorable, that make the favorable outcomes, that oppose the tax law and are female. So it's 60 out of the, we're selecting one person at random out of the 500, so it's always a 500. So it's 60 over 500 or 6 over 50. C. The person support, what is the probability of selecting a person who supports the tax or is a male? So there's an or here. How do you deal with or? In your book, there is a formula that says probability of A or B. It's called the additive rule. It is probability of A plus probability of B minus probability of A and B. So now maybe you're asking what is A and what is B. My A here is supports the tax, that's A. And my B would be is a male, so that's B. That would be my B. Okay. What is the probability of selecting a person who supports tax? Again, the possible outcomes, guys, it's 500, so we're going to divide out of 500. Supports tax. Well, here's the column that contains the support, and what's the total right here? It's a 300, so it would be 300 over 500 plus. Now B. What is the probability of selecting a person who is male? Okay, 500 is a denominator, no issue with that. Now, we want a person to be a male, so how many male? We have 247. 247 minus the probability of selecting a person who is a male and support tax. Okay, this is the row that contains the male, and this is the support column. Where would the two arrows meet, guys? You agree with me that they meet right here at 128. So it's 128 divided by 500, which equals to what? 300 plus 247 is 547 minus 128 will be 419 divided by 500. Okay, so that is the answer. Part D. We select a person at random. What's the probability that the person opposes the tax given that the person is a female? Okay, so opposes the tax, let's call it event A, and given it's a condition. He's telling us that I want the probability of selecting a person who opposes the tax given that the person is a female, so that's a given here, that's B. We write it like this, probability of A given B with a vertical line equals. Okay, now your denominator is not going to be 500. Why? Because he is conditioning us. He said, you select a person at random. What's the probability that this person opposes tax? Given that this person is female, so he's asking us, we only can select from the female group of adults. And how many female group of adults we have here? We have 253. So your denominator is going to change, and it's going to be 253. Now what is the numerator? The favorable outcome. We want the person to be a female but opposes tax. How many female are there who oppose tax? Right here, guys. You can see this. Who oppose tax? Where do they meet? At 60. So it is 60 divided by 253. E. What is the probability of selecting a person who is male given that the person supports tax? So male is A here, and the person supports tax is B, and I want the probability of A given B. It's the same thing as the previous one. Okay. He's putting us a condition that we only can select from the group given that the person supports the tax. So I only can support from the group of adults who support tax. What's the total number of adults who support tax? It's a 300, it's right here. So that's 300. Now, favorable outcomes. We want the person to be a male and support the tax. Male and support the tax, which is 128. All right, so that's E. Are the events male and opposes tax independent? Let's call this event A, and let's call this event opposes tax B. We say two events are independent if the probability of A times the probability of B equals probability of A and B. If probability of A times probability of B equals probability of A and B, then the events are independent. Well, let's check. What is the probability? Check. We're going to check on this. What is the probability of A? Selecting a male. Okay, total of male 247, so it's 247 divided by 500 times. Probability of B, opposes tax. What's the probability of selecting someone who opposes tax? 159 divided by 500. Let's check if they are equal. So I'm going to put a question mark here. Probability of A and B. A and B means male and opposes tax. Male is right here and opposes tax right there. So we got 99 over 500. Okay. What is 99 over 500? We'll use the calculator. 99 divided by 500 is 0.198. Let's see what's 247 over 500. This is 0.494. Times. We're checking if they are equal. 159 divided by 500, 0.318. Okay. What is 0.318 times 0.494? I got 0.157, which is different from 0.198. And your conclusion that the events are not independent because the probability of A times probability of B is not equal to probability of A